Hi guys, and welcome back to part 3 of the scientific method video lectures. We're going to start with step 5 in scientific method, and we last time, let's go back so you can remember what we did. We were talking about the different test groups, and we had 4 groups. 3 of them are test groups that were exposed to different amounts of pollution in the water where they were developing. So group 1 had some pollution in its water. Group 2 frog eggs had a little bit more pollution in their water, and group 3 had even more water pollution in their where they were growing. The control group, remember, was the group that did not have any pollution, so they were growing and developing in clean water. And so when we conduct this experiment or do the experiment, we're going to be collecting data. And in this case, our dependent variable, again, are the number of frogs who have deformities. So as these eggs develop into frogs, we're going to start counting the number of them that actually develop deformities. That's going to be the data that we collect. So once we collect that data, the next step of scientific method comes into play. We have to make sense of the data. We have to analyze it. We have to decide, what is the data really telling us? What kind of evidence is it giving us to understand the answer to our question or to help us solve our problem? Okay. One of the things that we do when we analyze and interpret data is we put it into a visual graphic of some kind. In this case, if you notice here on the page, let me do this. So if you go here on the, sorry guys, it takes me a minute. Okay, so, nope, I don't like that either. Let's see. What do we got? What's this one? What's this? Oh. All right. I'm just going to go back to a regular pointer, guys. Sorry about that. Okay. So I'm learning too. I learn something new every day. It's really exciting. Okay. So this is an example of a visual graphic or a visual representation of data that was collected. And I actually was able to find a graph that also had to do with an experiment about frogs. But in this case, rather than exposure to pollution, it was exposure to ultraviolet light that the scientists were testing. So their independent variable down here were the number of days that the frog eggs were exposed to ultraviolet light. And then their dependent variable, same as ours, in the Freaky Frog experiment, were the number of deformed frogs. And that's just counting, right? That was the data that they collected. So their independent variable was 0 exposure to ultraviolet light. Okay, so those guys were protected. So that was probably their control group. And then one group of frog eggs was exposed to 15 days of ultraviolet light. There were no deformities that resulted from 15 days of exposure. And then if you look at the very end, 24 days of exposure for to ultraviolet light by those frog eggs resulted in, look at that, probably it looks like 47 deformed frogs. So very significant difference, right? No exposure to UV light, no deformities. 15 days of exposure, no deformities. And then all of a sudden, when you get to 24 days of exposure, then you start seeing a lot of deformities in relation to the other 2 groups, right? Okay, so if you think about it, this visual graph is actually much easier than looking at, like just a whole list of data. When scientists do experiments, typically they will run hundreds, thousands, tens of thousands of trials. In other words, they'll run the same experiment so many times and they'll have so much data to analyze. So it's always a good idea to take that data that's just like listed in a table and create a graph like this one to help your audience understand and also to help you understand. You can see patterns, and sometimes depending on the data, you would use a bar graph. Sometimes you would use a circle graph, or sometimes called a pie chart. You might use a line graph. And so this year we will be working with some data, and you will learn how to actually create your own bar graphs and line graphs and circle graphs. So exciting stuff coming up. All right, the next step in scientific method, after you have done all the other things and you've collected your data, you've analyzed it, then it's time to draw a conclusion. And the conclusion in an experiment is basically a summary of that experiment, and it's a summary of what you learned from the data that you collected. When you analyze the data, what did it tell you? What did you learn? So you're going to have to answer a couple of questions within your conclusion statement. You're going to have to answer whether your hypothesis was supported or not. You're going to have to answer the question about what did the data tell you when you analyzed it. How did you interpret it? What did it mean to you? How did it either support your hypothesis or not support your hypothesis? Okay, and then you want to end up in your conclusion with a what next kind of statement. So, like if your hypothesis was supported, you can still learn more. So you might want to extend your same hypothesis. You might want to expand the number, the independent variable variations that you have. So rather than 3 test groups, you might want to do 10 test groups and just do gradual increase in the amount of pollution for each one of those groups, okay? If your hypothesis was not supported, you might want to go back to your observations, to your research, and look at all the things that you know about the frogs and decide, maybe do I want to look at another factor? Maybe it's not the pollution. Maybe it is like ultraviolet light exposure or something like that in the environment that's causing the deformities. So in your conclusion, you always want to end with what you would do next. How would you extend your thinking? How would you continue to ask more questions and learn more about that particular problem? Okay, then after you've done all that, you're still not done. Oh gosh, it goes on forever, right? So the last step of scientific method is very important because we always want to communicate our findings. We want to communicate our results. We want other people to know because that's going to help build the collective background knowledge for people, whether it's your peers, whether it's, my audience. Your audience is me, and I'm trying to determine if you understand how to use scientific method, or if you did your procedure correctly, if you collected the right kind of data, if you analyzed the data correctly. So like for an assessment. And then there are other audiences too. So you always have to share your experiment and your results at the end. You can communicate by speaking, like giving a presentation of some kind. By writing, we will always do a lab report. We have a kind of a lab report template that we'll use. It's going to be different from note taking, and we're going to be going through that whole process here with this unit on scientific method. Anyway, you're going to get a lot of practice in writing that. So that's scientific method in 7 steps. I hope you learned a lot, and we are going to be practicing this in class. So don't be too worried if you still don't get it. You can always ask for help, and we're going to practice it a lot. All right. Thank you.